we're going to find the depth of the water when H is equals 2. This is like looking at the point at the moment in time, so we're not going to use this H equals 2 for a little while. We're not going to use it for a little while. But when I get done, before I give an answer, I'm going to go back now and say, okay, now I know what the derivative is, but now at this moment in time, the specific derivative, the specific rate of depth of the water is. And so we're going to have to hang on to it, but don't use it too soon. This information cannot be used until the very end. What are we given? We're given the derivative of volume with respect to time is how much? So 3 cubic meters per minute. Okay? And we already have, we're going to use this up here. Okay, I need to find dH dt. dH dt. If I'm going to use this, by looking at this, can you tell will we get a dH dt if we take the derivative of volume with respect to time? What? I don't have to. Oh, I don't have to solve for H. Okay? I could, but why complicate our work, okay? I could. If you want to work extra hard, be my guest. I'm a lazy mathematician. I will avoid extra work if I can. And you will too. So I'm showing you that you don't have to solve for H. Okay, but if I look at the derivative of volume with respect to time, am I going to get a dH dt out of this? H is not t, right? So it is a function of time, and so I will get a derivative there. 1/3 pi, constant or variable? Constant, okay. Do you see a product up here? Good. So what's the first rule you're going to use? Product rule. Yes, product rule. Okay, so here we go. We're going to take the first factor, and I'm going to make it pi divided by 3h times, hang on just a second, the derivative with respect to time of 108 minus h squared plus the second factor, 108 minus h squared, times the derivative with respect to time of pi divided by 3h. Yeah, Jordan?
So why isn't it, I thought we were finding the dH. So
We are.
we write it, why is it?
Well, because we're using this.
Okay.
Okay, if I use this formula and I find the derivative with respect to time, as you can see, we are going to get some dH dt's out of that. Any other questions? You know, use what you're given to build the derivative and then go back and make the substitutions. Yes?
My question is how we are supposed to write like what we found, what we're given, and what we use. So did we just not write out what we're using?
I do up here.
Okay.
Again, I'm just being lazy. Okay? Yeah, just being lazy. Now, if you had it written on a piece of paper, I would allow you to do the same thing. Okay? But you're going to want to write it out probably because you're going to get it on the Inspire. Okay. So let's see. I'm not going to put any substituted values in until I get down to taking all my derivatives. So I have derivative of volume with respect to time equals pi 3h. And then I look inside here, the derivative of 108, I don't care what variable of differentiation, is still going to be 0 minus, okay, now remember, h is not t, so h is a function of its own, so I'm going to have, the outside function is squaring, so I'm going to have 2h, and then I'm going to have the derivative of what? Yeah, the derivative of dh, a derivative of h with respect to t, okay, plus 108 minus h squared And this derivative, I've got the coefficient pi divided by 3, so I'm still going to have pi divided by 3 dH dt. Okay. I'm trying to find dH dt. So I could, before I do anything else, factor out some information. I mean, actually, I won't factor yet, I guess. Well, let's see. This is gone, isn't it? We can just kind of get rid of that. So this is all one product here, and I've got a pi divided by 3 dH dt. I better do. Yes. Okay, let me finish this, and Heather, this one? This one? That is a negative there. Thank you. How about that? Okay, so we've got that. Thank you. Then I've got, let's see, 108 times pi divided by 3. I believe 108 is a factor of, or a product, excuse me, multiple of 3. Okay, so I have plus 36 pi dH dt minus pi h squared divided by 3 dH dt. Okay, now I see I've got 1, 2, 3, and I can factor out a dH dt from both of those and a pi from both of those. I may just do the dH dt. Negative 2 pi h squared divided by 3 plus 36 pi minus pi h squared. I guess I could combine those, couldn't I? The pi h squares divided by 3. That would be what, negative 3 pi h? Yeah. Okay. So I'll keep that in mind, that these two terms will be just pi h squared here. Just kind of keep that in mind. Okay, now I'm down to the point where I've taken all the derivatives. I've got it, kind of simplified here. What are we given? Well, we're given that dv dt is 3. So I'm going to go back and put that in. And I'm looking for dH dt. And I've got, what do we say this was? Negative, so I've got 36 pi minus h squared, okay, pi h squared, and I want to find dH dt, so I've got 3 divided by that. Does that seem reasonable? So all I'm doing is algebra now, and this is the part where some of you, or you're like me, I mean, we get tripped up. There's a problem that someone asked me about with in homework that, oh my goodness, I spent a few minutes of my own time trying to get my answer to match up with what the answer the WebAssign has, and I'm thinking, why did they do it that way? They gave you an awful answer, and it's really rather simple. But we spend our time doing that. I want to minimize what we can do with that, but at the same time, come up with an answer here. Heather, you see something we can change?
Well, I don't know why Fagan
This one? Okay. Now, this is when I'm going to use this. When h is what? What was that? 2. Okay. So now I'm going to use that, and I have dH dt, given that h is equal to 2, is 3 divided by 36 pi minus, let's see, 2 squared is 4, so that would be 4 pi, or 3 divided by 32 pi? What are my units? What are my units here? Okay, I go back to the original problem to find that. What were we supposed to find? The rate of change of the depth of water. So the units here would be what units? Meters per minute, right? Now, let's think about this problem. Who really cares? I mean, don't you ask yourself that question every now and then? So what? I got an answer. Who cares? Well, let's try and build a reason why you'd want to know this. Where do we start? We have this hemispherical water tank, right? And we're trying to find the rate of depth. Now, by the way, if I were out in the real world, not the mathematical one we're in, I wouldn't walk around talking about 3 divided by 32 pi meters per minute. I'd probably use an approximated value. Hopefully yours comes out the same way mine does. It's 0.0298 meters per minute, right? Even so, who cares? Well, let's see. You got this hemispherical water tank. You've got water coming into the tank. Water's coming in. How fast is water coming into the tank? How fast? 3 meters per minute. Okay? And the water is how deep now? 2 meters? About how many feet? About 6 feet. Okay? Let's suppose MacGyver is inside this water tank. Okay, you know about MacGyver, right? MacGyver was on the Saturday Night Live spoof of that. MacGyver is a guy who could just create the amazing tools out of nothing. So he's inside this water tank. Now he's not 6 feet plus tall, but that's what 2 meters is. So he's standing on a box, okay? He's got just a few minutes to live. How long does he have to live before the water's going to be too deep for him? Well, it's already at 2 meters. How fast is that height, that depth of water changing? Now, 0.03 meters per minute. Okay, do something else. About how many centimeters? 3/100 of a meter is about how many centimeters? 3 centimeters, okay. So this water is rising at about 3 centimeters per minute. He doesn't have much time to live. He's got to find some way to get out of this hemispherical water tank with the water pouring in. Now, doesn't that make it seem a little more interesting than just finding an answer? Yeah, thank you. Thank you. Okay, anyway, I don't know if MacGyver's in there or not. I didn't draw him in, but we could. Anyway, now let's think about this. This is when the height of the water is 2 meters. When they start pouring water in, is the rate of the depth of the water faster or slower than when it's at 2 meters? Jessica? The depth of the water is rising faster when you first pour it in? Now you think about it, if I'm going to pour water in here, okay, the depth of the water is increasing, the depth's increasing at an increasing rate as more water gets poured in. Have you ever poured water into a big basin? What happens to that water when you first pour it in? Yeah, it disperses all over the bottom of that. But as you are pouring more water in, what's happening to the depth of water as more water goes in? The rate is increasing, okay? The depth of water is increasing at an increasing rate. Am I about out of time?